Hello! Here, we will revisit the status of the Zero Swarm North Node Trial 3. This trial is led by AALTO University. This trial is motivated by the emerging developments in the manufacturing sectors. The combination of emerging sustainability-related regulations, such as the Eco-Design for Sustainable Products Regulation, and the shift in the European Union occupational safety and health to focus on the improving prevention of workplace accidents and illnesses, created opportunities for improvement, but also challenges to compliance. The emergence of the Industry 5.0 paradigm is aligned to this, however it is not fully known what and how this concept shall be used to improve the manufacturing sector company's state of business. In parallel, the post-pandemic era has created the so-called new normal, where we see different way of work, where we see more geographical agnostic way of work, remote or on-site. The pandemic and increased geopolitical instability have nothing but provided a wake-up call that companies need to be resilient in order to survive and keep thriving. On-the-fly adaptation should be easily done, correctly to fulfill business and technical needs, timely, and without being costly. As such, accurate simulation of processes and systems are imperative in order to validate that changes fulfill the necessary business and technical properties. Accurate simulation, representative to the real world, requires real-world data. Our trial intends to address these emerging challenges by applying the so-called smart ergonomics concept, where having accurate simulation model will open the possibilities in improving work conditions while respecting the overall operational performance. The key prerequisite will be how to develop the so-called human digital twin, which facilitates the creation of accurate human simulation model in order to realize smart ergonomics. The capability to realize smart ergonomics has a number of potentials. Safety assurance is a golden requirement in industrial sector like manufacturing, but smart ergonomics can improve safety assurance. Simulation with accurate human model can be utilized to improve productivity and also enable flexibility needed to adapt to disruptions. This trial is realized at the AALTO Factory of the Future Testbed at AALTO University, a testbed to investigate innovation in advanced information technologies applied to future industrial systems. The testbed benefits from flexible layout enabled by modular, autonomous production units. The testbed is connected to AALTO 5G test network. The trial is based on the following high-level architecture. An automated assembly line, based on the IEC 61499 distributed automation standard, replicates simple pick and place assembly processes. An autonomous mobile robot with an attached robotic arm navigates between a manual assembly workplace and the automated assembly line. A decision-making module analyzes the environment and provides recommendation on tasks and schedules to the human, assembly line, or the robot. The trial considers this scenario. The MIR robot puts the workpiece to the assembly line to be processed. Upon completion, the human worker takes the piece from the line to the workstation. Once the piece is processed by the worker, the piece is finally moved for storage. This short clip shows a recording of the robot moving the piece towards the IEC 61499 automated assembly line, where it carries out some assembly processes. A key piece of technology in this trial is the development of a human simulation model. This model is built on top of the Visual Components Simulation Actor model, adding a set of information with data from wearable sensors as seen in this image. And this clip shows the initial result of the human digital twin, which is used in the Visual Components Simulation platform, replicating the trial scenario done in the real world. Finally, thank you for watching, and stay tuned for more updates in the future.